My name is Kirschner, and together with Hoorn, we did a review on the history of grasses in Amazonia. This work was part of my master's in earth sciences at the University of Amsterdam. It's now published in Frontiers of Biogeography, and we're really excited to present some of our highlights. The grass family, or Poaceae, comprises more than 11,000 species. You can find grasses in every ecosystem and on every continent except Antarctica, and about 40% of the Earth's surface consists of grassland. That means that grasses contribute to altering carbon cycles and the climate system, which is why resolving the role of grasses in the past is key to understand ecosystems today, especially in regions with such exceptional biodiversity like the Amazon drainage basin. So in Amazonia, Poaceae make up a principal component of several biomes. There are temperate and cold grasslands like the Puna and the Paramo in the high Andes. They grow in floodplains and they are present as flowering grasses in tropical forests. And there is savanna grasslands like the Cerrado in Brazil or the Llanos in Colombia. Our main question for this review was therefore, can we date the onset of grasses in the Amazon drainage basin and reconstruct the role they had since then? So how do we know about grasses of the past? What we did is we searched for literature on fossil records.
And the fossil record is an excellent resource when wanting to reconstruct plant history. So you could find plants, plant remains, leaves, trunks, but also the smaller parts like phytoliths, biomarkers, and pollen. And pollen, the reproductive material of plants, is really ubiquitous in the fossil record. And just to give an example from Amazonia, if you take a thimble of sediment from outcrops along the river, you could find thousands of species. So they can represent the past biomes and also give us an insight into Poaceae history.
So there's a number of studies done on fossil records in Amazonia. All the black points you see on this map with the little letters are studies we considered in our review, where Poaceae pollen and phytoliths indicate the presence of grasses.
So from the fossil record, we know that about 23 million years ago, so at the turn of the Oligocene to Miocene, there's already fossil Poaceae, for instance, in the coastal regions in the Guyanas. They could be even older, but that's our record at the moment. And from Western Amazonia and the Amazon submarine fen, there is records from 18 to 80 million years to Pleistocene.
We also know about different environmental processes, such as the rising Andes and sub-Andean basin subsidence. We know about the wetland that was in Western Amazonia and changes in the drainage system. There have been megafans on the hills of the rising Andes, and of course climate change throughout the whole period with a great impact on the environment. So let's now zoom into these two key records that we marked in red with the circles, one in Western Amazonia and one at the Amazon submarine fen. So the fossil record from Western Amazonia spans from 18 to 10 million years ago, and the one from the Amazon fen reaches from the early Miocene until present. And you can see Poaceae in red and other angiosperms in green. And so these diagrams, they underline our hypothesis that there was 3 different stages of grass development in the Amazon drainage basin. So the first stage we proposed was from 23 to 9 million years ago. At that time, the central Andes Plateau had an elevation close to 3,000 meters. If you look at the little map at the right side, you can see the continental drainage divide marked with the little black arrow, still in the centrum of northern South America.
Yeah, this wetland system was quite an amazing system. It covered about 1 million square kilometers, and the present Amazon region is defined as about 8 million, so it's about 1/8 of the present area. And for comparison, the Pantanal is about 200,000 square kilometers. So it was really a very big wetland system that harbored a wealth of fauna, very diverse fauna, and also probably hosted these Poaceae that we see in the Western Amazonian record. Nevertheless, there could also have been a Poaceae source in this already high Andes. So we basically have 2 possible sources, and it will be very interesting to find out which one is which and if they both are represented in that system.
So then the second stage would be from 9 to 3.5 million years ago. At that time, the Eastern Cordillera and the Central Andes reached an elevation of around 4,000 meters. In consequence of Andean uplift, the wetland disappeared, the drainage divide moved westwards, and the Amazon River connects the Andes to the Atlantic. We know that landscapes in Western Amazonia are marked by very high sedimentation and megafen formation, which is also reflected in the Amazon fan in form of increased arrival of ambient sediments. And in addition, the amount of grass pollen in the Amazon fan rises, what you see in the pollen diagram, which is why we suggest the ambient slopes are a likely origin of these grasses. In addition, we think that there has been an increase of grasses on the Amazon River floodplains, with some contribution also from the establishing Cerrado in the southern part of the basin. The third stage would be from 3.5 million years ago onwards, where we observe a further increase of grass pollen and ambient sediments in the Amazon fan. The Andes are now close to present height, and so we suggest the paramo in the high Andes could be one source of these pollen. There must have been ongoing geomorphological changes connected to glacial and interglacial intervals, with the paramo extending during the cold phases. And at the same time, megafans and lowland floodplains likely continued to host significant amounts of grasses. This has been a brief overview of our review, and of course now these hypotheses remain to be fully proved. Two really important ways forward would be to identify fossil poaceae pollen and phytoliths to subfamily level as well, because that would give us important indications on the original biome, and then also to improve modern calibration studies.
So after the paper was accepted and published by Frontiers, there were some new papers that came out, which were very exciting for us to see and already provide new insights. For instance, Akabani et al., who is their paper on modern pollen signatures from the Amazonian rivers, provide a sort of calibration set for environmental reconstructions. So that's a new interesting hook. It's always important to reflect also what time frame, where are we climatologically, because this example is from a time from the present, but of course in the past we have had glacials in which sedimentation patterns have been different. The other paper that's really interesting is, for instance, by Bicudo et al., who review and analyze the importance of Andean uplift and subsidence at the foot of the Andes due to subsurface processes, and how this affects changes in environment, and how these big, large-scale processes affect actually also landscape and even plants and the smaller parts of the system, such as the poaceae in the system. So from large scale to small scale, that's something we reflect on.
So thank you very much. And please reach out with your ideas and comments to us. I have now started a PhD in a slightly different topic. I work on fire resilient governance.
And I am at the University of Amsterdam with a long-standing interest in Amazonia, but also in other parts of the world, and especially on the poaceae. Thank you.
Thank you so much.